Welcome back learners. As you know that we are studying chapter 4 which is structure of atom. Students, in this chapter we have studied various models of atom and we have studied the subatomic particles. It's time for in-text questions. So we are starting from the very first that is on your screen. It's what are canal rays? So students, the stream of positively charged particles produced in the sample of a gas during electrical discharge is called the canal rays. Okay, now let's move to the question 2, that is, if an atom contains one electron and one proton, will it carry any charge or not? Look, we all know that electrons are negatively charged while your protons are positively charged, and they both carry equal charge but opposite in sign. So, the charge of electron will be cancelled by the charge of one proton. Now, your atom will be neutral, so there will be no net charge. Now, the next question on your screen is, on the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. So, students, according to Thomson's model, in an atom the total positive charge on the sphere is equal to total negative charge due to the embedded electrons, and that is why the atom as a whole is electrically neutral. This was the answer. Let's move to the next question, which is, on the basis of Rutherford's model of an atom, which subatomic particle is present in nucleus of an atom? So, this is the question, and the answer is, student, proton. Because you must remember that Rutherford's model was on the basis of alpha particle scattering experiment, and alpha particles are positively charged. A positively charged particle will be repelled by a positive charge. We know that those alpha particles were scattered from the nucleus just because the nucleus is positively charged and because of proton. So that's why on the basis of Rutherford's model of an atom, we can say that proton is present in the nucleus of an atom. Now, third question, that is, you have to draw a sketch of Bohr's model of an atom with 3 shells. So let me show it to you. So students, you can see here the picture clearly. This is the nucleus, K shell, L shell, M shell. You have to draw up to 3 only. So draw these electronic shells along with the nucleus. This is the drawing. This is the sketch for Bohr's model. Now let's move to the other questions. The next question is on your screen. It is, what do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than gold? So students, gold is highly ductile and a heavier metal. If the particle scattering experiment is carried out using a foil of any other metal, most of the alpha particles will be absorbed by the metal foil and a very poor scattering of alpha particle will occur. That's why Rutherford selected gold foil. Now, few more questions are remaining. The next question on your screen is, name the 3 subatomic particles of an atom. Students, we have studied this thing in detail. We know that there are 3 subatomic particles named electron, proton and neutron, out of which proton and neutron resides inside the nucleus. They are called nucleons, while electron rotates around the nucleus in various shells, which you call as K shell, L shell, M shell, so on. So, now the next question is, helium atom has an atomic mass of 4U and 2 proton in its nucleus. How many neutrons does it have? Students, atomic mass is represented using symbol capital A. Now, this is equal to number of proton plus number of neutron. You know that you are having atomic mass 4, okay, and number of proton are 2. So you can easily subtract and you can get the number of neutron. You will get 4 minus 2 and the number of neutron will come up to 2. So a helium atom is having 2 protons, 2 neutrons and the mass is 4U. That's all for today, students. Keep learning, keep asking.